from ray optics, where we will see the derivation, how the refraction through a prism is happening, what is the formula which is derived, and we will also see the numerical on it. Okay, let us consider that a triangular prism is given to you, right? Triangular glass prism like this. Okay, if you see the glass prism, this will be looking like this. Okay, and this is triangular in shape, right? So if there will be an incident ray, and this will be the normal, right? This will be normal to the surface, let us say a b. If this is the reflecting surface, right? If this is the surface through which the refraction happens, right? Because the medium is changed. Yeah, here the medium is something and here something, right? This is air, this is glass, right? So from here, if we can see that as if this will be the angle of incidence, if this is the incident ray and this is the angle of incidence, this is angle of incidence, right? So from here, the light goes from rarer medium to denser medium, and it will just turn towards the normal like this, right? And then again denser to rarer. Then at this surface again the refraction will happen, and from here, from denser to rarer, when the light ray moves, right? This is the incident ray, it goes through the glass like this, and from denser to rarer it goes away from the normal, so it will just move like this. Okay, and this will be the angle of emergence. That means when the light coming out from the prism, this is the angle of emergence, right, my dear friends? Now sorry, the angle of incident is considered on the surface AB, and angle of emergence is considered on the surface AC, right? Both of these are glass surfaces, right? Now from here we can see, while the angle of incidence and angle of emergence, you can see I and E, right? We can say that this is the let us say this, extend this normal over here and this normal over here, and let us say this quadrilateral is formed. I'm just taking the same which is taken into the NCERT N, right? And here Q, and let us say this is R, right? And this angle is R1, angle of refraction at surface AB, and this is the R2, which are where R1 and R2 are the angles in the denser medium, right? Because this is the glass prism which is made up of glass, right? So that's why refraction is happening over here like this, right? Now the angle between the emergence ray, let us say this is the emergence ray, right? Let me write it. Emergence ray or emergent ray, this is the emergent ray and this is the incident ray, this one, right? This is the incident, this is the emergent, right? Now from here, the angle between the emergent ray and the direction of incident ray, right? So this will be, if you extend it like this, the incident ray and the direction of emergent ray here, if you just extend it like this, then this angle will give you certain deviation, right? And this will be your angle of deviation, this will be your delta, this will be the deviation. right? Now into this figure we can say that if you can see the quadrilateral AQNR, right? AQNR, because QN and NR are the normal to the surfaces AB and AC. So therefore we can say that angle AQN is equal to 90 degree, because QN is normal, perpendicular, or we can say normal to the surface, normal to the surface AB, right? So that's why angle AQN is 90 degree, right? Similarly, this NR is a normal to the surface AC, right? So we can say that angle ARN is also 90 degree. Why? Because NR is a normal. NR is perpendicular, or we can say normal to the surface AC, this surface, right? So my dear friends, if you consider the quadrilateral AQNR in quadrilateral AQNR, what will happen? This angle AQN is 90 and ARN is also 90. So that means we can say that angle A plus angle AQN plus angle N plus angle ARN, all this will be added together, and you know, all the sum of all the angles of a quadrilateral, of any quadrilateral, is equal to 360 degree, isn't it? Sum of all the angles of a quadrilateral is 360 degree, but AQN, this is we have seen being a normal, this is 90 degree, and ARN being a normal, it is also equal to 90 degree, right? So we can say that, just write angle A and N as it is, right? So we can say that if 90 plus 90 is 180 and into the RHS we have 360 degree, we can say that angle A plus angle N, angle N is basically this one, right? This one, which is equal to angle QNR, right? Angle N is basically, this is basically angle QNR, right? So this will be giving you 360 degree minus this 90 and 90. So minus 90 minus 90. So this will give you angle A plus angle N is equal to 360 minus 180, which is equal to 180 degree, right? So my dear friends, we have angle A plus N as equal to 180 degree. Angle A is this angle of the prism, right? And angle N is this angle, right? So we get the value of A and N as equal to 180 degree, right? Now, when you compare the equations, right? If you consider triangle QNR, right? So we can say that in the triangle QNR also, the sum of all the angles will be 180 degree, isn't it? Let me show you. If you see, in the triangle QNR, Q N R. What will happen in the triangle Q N R? Angle R1, angle of reflection for the first surface, plus R2, angle of reflection at the second surface, right? Because this will be equal to E, right? Almost equal to, not exactly, because these are not the straight lines, and this line will go in over here between E. Anyway, so R1 plus R2 plus this angle N is equal to 180 degree, isn't it? Because this is a triangle, and this will give you the value of angle N. R1 plus R2 plus N is equal to 180. So this will give you the value of angle N as 180 minus R1 or R2. So we can write angle N as equal to 180 degree minus R1 minus R2. So it becomes R1 plus R2, right? So this will be the value of angle N from here, right? If you substitute it over here, right, we get angle A plus, instead of N, write 180 minus R1 plus R2. So just put it over here. We get 180 minus R1 plus R2 is equal to 180, right? Here this will cancel 180 and 180, and we will get R1 plus R2 going into the RHS, which will be equal to angle A. So we will get angle A is equal to R1 plus R2. What is R1? R1 is angle of reflection for the layer 2, for the first layer, and R2 is this angle with the normal, right, for the layer 2, which is second surface AC, when the ray is emerging out, right? So this relation we are having, right? Now, if you see the sum of the deviations, right, the total deviation is the sum of the deviation of the two surfaces. So what is the deviation over here? It is equal to I minus R1, and sum of deviation over here is E minus R2, right? So if you will see the deviation, right, we can see it like it. Total deviation is equal to deviation at the two faces. Deviation at AB is equal to deviation at AB plus deviation at AC. Just write it separately. What is the deviation at AB? Deviation at AB, this surface will be I minus R1, isn't it? Angle of incidence minus angle of reflection. So this will become I minus R1. So at this surface, deviation at AB becomes I minus R1, and at this surface E minus R2 will give you the angle of deviation. So just add E minus R2. So this will give you the deviation at surface AB and deviation at surface AC, right? So that's why we have mentioned I minus R1 and E minus R2. So this will give you the total deviation, right? So we can say that I plus E minus R1 plus R2 is the total deviation. total deviation which is equal to delta. Delta. This is the deviation, right? So this is the total deviation delta, and R1 plus R2 can be substituted from here as equal to A. So can we write it I plus E minus A is the total deviation delta. This one, deviation delta, is equal to I plus E minus A. Right, my dear friends? So this is the total deviation delta which we have identified. So let me write it over here. Deviation is calculated, and that is equal to I plus E minus A. I plus E minus A. Right? This is the same thing which we have derived. Okay? This is the same thing which we have derived. Right? Now, the angle of deviation depends upon the angle of incidence. So you can see a separate plot is also shown into the NCERT, right? Anyway, now except for this, if you can say, if for a small deviation, right, for the minimum deviation, the reflected ray inside the prism becomes parallel to its base, right? For the very small deviation, the refracted ray becomes parallel to its base. The refracted ray, that means QR, right? When for a small deviation, QR is parallel to this is QR. If this QR is parallel to this BC, right, this is the BC base, right, for the minimum deviation, then we can say that I will be equal to E. When this will be parallel, then I will be equal to E, right, which implies R1 equal to R2, right? So let me write, for minimum deviation, we can write angle of incidence equal to angle of emergence, right? And when angle of incidence equal to angle of emergence, this gives you R1 is equal to R2. This R1 equal to R2. When I equal to E, then definitely R1 equal to R2, right? R1 equal to R2, right? So into this condition, we can say that if R1 is equal to R2, then R1 plus R2, just put it over here, R1 plus R2, when R1 and R2 are equal, then 2 times R1 equal to angle A. Or we can say that if R1 and R2 both are equal to R, right, then what this equation will give to you? This one. Then since angle A equal to R1 plus R2, so this will give you angle A is equal to R1 plus R2, and since both are equal, we can write it as R plus R, right? So we can say that angle A by 2, because angle A equal to 2R, so we can write that angle A divided by 2 is equal to R, right? Is equal to R. Right? Now, in the same way as we have shown from equation this, from the above equation, right? Which one? The above equation which we have taken, this angle A equal to R1 plus R2, and another one is angle for the deviation I plus E minus A equal to delta, the total deviation, right? We can show that the small deviation, the delta, is equal to 2i minus a, right? This can be written as I, because I is equal to e, so delta can be written as I plus I minus a, right? So let me show you. For a small deviation which we have taken over here, then delta is equal to I plus e minus a, and I is equal to e, so we can write it as delta is equal to I plus e minus a, this formula, right, which we have derived now. Or we can say from here also I plus e minus a, right? And what is I is equal to e here, right? So we can write I plus I minus a, because I is equal to e, right? So this will show you the deviation delta is equal to 2i minus a, right? 2i minus a, or this delta, which can be, if you are writing delta as equal to d, if this is equal to d, right? If this delta is equal to d, the deviation, right, then we can write d is equal to 2i minus a, or we can write d plus a by 2 as equal to I, isn't it? D plus a by 2 is equal to I, right? So that's why the refractive index of the prism to 1, because if mu over here is 1, and let us say it is mu 1, and here it is mu to the glass, right? Then into this case we can write that mu to 1, that means this to this, right, is equal to how much? Sine of I, right? Sine of I by sine of R, right? Sine of I by sine of R. And what is sine of I? Put I as d plus a by 2 from here, and and R as a by 2 from here, right? So this will give you, since I equal to d plus a by 2, just write sine of d plus a divided by 2. This will be into the numerator, and into the denominator we have sine r. So r is equal to a by 2, here you can see. So we can write sine of a by 2 into the denominator. Since I is equal to d plus a by 2, which you can see over here, we have proved, and r is equal to a by 2, since we have proved over here, you can see, right? So this will be the formula, my dear friend. This will be the formula which is generated, right? Refractive index for a glass prism with respect to the angle of deviation can be shown as mu 2 1, right, is equal to sine I by sine R, which is equal to sine d plus a by 2 divided by sine a by 2, where this is the condition. Mu1 is the refractive index at air, mu2 is the refractive index of glass. Again here it's mu1 because again it's coming into the air, right? And into this condition, this will be the let me show you. This will be the entire formula which we have derived, right? Now from this space, I want to just take one numerical. Numerical is that the minimum angle of deviation of a prism. Okay, so this formula, how the derivation is coming, we have shown you, right? I have shown you. Now let us take that numerical when the minimum, one question on it. Okay, though I put a shots of it also, but I want to show you. Yes, we can take this page. Yes, so let me take it like this. So the question is that the minimum angle of deviation of a prism. Question is that, question on is it is minimum angle of deviation of prism is equal to its refractive angle, right? Is equal to its reflecting angle. This is given that the minimum angle of deviation of a prism is equal to its refracting angle, is equal to prism's refracting angle. This is given to you. So when this is coming in front of you, that means D is equal to angle of deviation, D is equal to A, right? If you remember the figure, which we have derived, this one, where was D? This was D, this is A, right? Now for this, what we have derived, this is the formula, sine of D plus A by 2 divided by sine A by 2, which is the value of refractive index, right? So using this formula, what we can write, using this formula, just write it over here, that yes, what we have proved is mu is equal to sine of D plus A by 2 divided by sine of A by 2, this one, right? So using this formula, let us proceed forward, right? When you just proceed forward using the same formula what we have derived, this one, right? The numerical to us is that the minimum, this is given that minimum angle of deviation of the prism is equal to prism's refractive angle. That means D is equal to A. This is the condition given to you, right? Now it's also given that the refractive index is 1.732. It's also given that mu is equal to 1.732, right? If mu is given as equal to 1.732, my dear friends, right, then into this case you just substitute the value of mu over here at 1.732, right, into the LHS, and we have sine of D plus A divided by 2. So we can write, since D is equal to A, can we write sine of, instead of D, just write A. So it will be A plus A divided by 2, right, divided by sine of A by 2. This will give you 1.732 is equal to sine of A plus A becomes 2A. 2A divided by 2 becomes A. So sine A divided by sine A by 2. My dear friend, can we write sine A as sine of 2 into A by 2? Can we write it? 2 will be cancelled out, right? Why we are writing it? We are writing it like this because if you remember the formula of sine 2x or sine 2 alpha, sine 2 alpha is equal to 2 times sine alpha into cos alpha. You remember this formula? So we will be using it over here, right? Use it over here. Then this will show you the numerator becomes sine 2 alpha. So instead of for alpha is equal to A by 2, this entire equation becomes 1.732, which is basically root 3. The value of root 3 is equal to sine 2 alpha. Sine 2 alpha is 2 times sine alpha. Since alpha is equal to A by 2, so 2 times sine A by 2 into cos A by 2, isn't it? Just remember the formula of sine 2 alpha, right? And into the denominator it's sine A by 2 already there. So my dear friends, all the numbers into all the trigonometrical ratio into the numerator is in product. So definitely sine A by 2 will be cancelled with this sine A by 2 present into the denominator. So this will give you this 2 coming to the LHS. So root 3 by 2 is the value of cos A by 2, right? In the question it has been asked that what is the angle of the prism. This angle was asked, right? So to calculate this angle, you can see root 3 by 2 is the value for which cos? Which cos is root 3 by 2? If you remember, it's cos of, tell me, root 3 by 2 is the value of which angle? Root 3 by 2 is the value for what angle? In cos, it's cos 30 degree, right? So if you just compare it, you get A by 2 is equal to 30 degree, right? And that's why into the next step angle of the prism is calculated as 2 into 30 degree, which is equal to 60 degree, right? So into this question, if you remember, this was the angle of the prism, right? This is calculated as equal to 60 degree, right? This 60 degree is basically this angle of the prism, right? And what was delta? What was d over here? D is this one. This is the deviation angle, right? This was the concept. Where angle of incidence was this I. This is the incident ray under the glass refracted and moving towards the normal inside the prism, again going from denser to rarer medium, then again going away from the normal, right? So we derived the formula. Refractive index is related as sin I by sin R, which is equal to sin D plus A by 2 divided by sin A by 2, right? And using that we solved one numerical and we calculated the angle of the prism as equal to 60 degree. So thank you my dear friends for watching this, and hope you understand the concept of this deviation angle and how it's related to the refractive index. Just remember this formula. I will say mu is equal to sin I by sin R, which is equal to sin D plus A by 2 divided by sin A by 2, right? Using that you can solve all the question related with refraction through a prism, right? Thank you so much for watching. Take care. Bye bye. See you into the next class, my dear friends. See you. So as usual, I am writing the name of my channel into the last at the rate TECHNO Techno, because I am going to just wind up the session for today. Thank you so much for watching, my dear friends. Take care. Happy learning. Bye bye.